Did you know that behind the familiar image of the pine tree each Christmas season, the pine family actually generates more than $1 billion in annual revenue from pine resin, and also provides a fatty nut whose value rivals that of Wagyu beef? This journey begins with rugged pine trunks deep in the forest, where streams of golden resin are harvested after many years of accumulation during the tree's growth. As soon as it leaves the trunk, the resin is sent into distillation lines, becoming the foundation for hundreds of modern engineering materials and industrial additives. At the same time, mature pine cones are collected and left until their shells naturally open, releasing pine nuts, a nutritional treasure few people know about, yet one whose value far exceeds that of almonds, walnuts, or cashews. Today, join Agriculture Insight as we trace this journey and uncover how pine trees are harvested and transformed into a vast range of products that serve millions of needs in modern life. Although the pine family includes more than 120 species, only a small fraction is exploited industrially in three main directions: resin pines used for engineering materials, nut-producing pines that yield high-value fatty seeds, and Christmas pines, trees cultivated primarily for the holiday season and rarely involved in modern industrial supply chains. Yet beyond their economic value, pine trees possess a survival mechanism that continues to astonish scientists. Many species not only survive wildfires, they actually depend on fire to regenerate. Extreme heat causes pine cones to snap open, releasing seeds onto mineral-rich ash, where a new generation can take root. This very mechanism is why forestry authorities in the United States and Canada practice controlled burns, simultaneously triggering natural regeneration and reducing the risk of catastrophic wildfires. And fire is not the only force pine trees have learned to defy. Time itself is another. In California's White Mountains, the Methuselah pine, a bristlecone pine, has lived for more than 400 to 800 years. Long before the Egyptian pyramids were built, it had already taken root on barren, rocky slopes, enduring to this day as one of the oldest living witnesses in human history. Every Christmas season, tens of millions of pine trees are brought into living rooms, shopping centers, and public squares around the world. But have you ever wondered where these trees come from and how they are harvested before appearing in your home? The harvesting of Christmas trees is far from random. Only trees that have undergone 7 to 15 years of growth, reached standard height, developed even foliage, and achieved a well-balanced shape are selected. Long before harvest, they are regularly pruned over many years to shape their form, ensuring that each tree offered for sale stands straight, full, and symmetrical. When the harvest season begins, workers use handsaws or chainsaws to cut the trees close to the base. The felling process is carried out with great care to avoid breaking branches or disturbing the canopy, as even a small mistake can significantly reduce a tree's market value. Once cut, the trees are gathered and transported out of the fields by hand, small trailers, or conveyor systems. On large-scale farms or in difficult terrain, helicopters are used to lift bundled trees from the fields to collection points, saving time and minimizing ground damage. At the processing area, the trees are fed through net wrapping machines. This mesh tightly compresses the branches, preserving the tree's shape throughout transport while also reducing needle loss. After netting, the trees are slid into cardboard cartons to secure their form, protect the branches, and prepare them for shipment ahead of the Christmas season. From a tree that quietly grew for decades in the forest, the Christmas pine enters your home as a symbol of the holiday season. Yet behind the twinkling lights and festive decorations lies a harvesting and logistics process that is meticulously organized and executed with precision at every step. Across the vast industrial pine plantations spanning hundreds of thousands of hectares in the southeastern United States, the resin harvesting season runs steadily for 8 months each year, a rhythm that has remained nearly unchanged for centuries. The process begins with the selective scraping of the outer bark to create a stable surface for subsequent operations. Workers then use a resin axe, a specialized tool with a square head and beveled blade designed specifically for opening resin channels, to make a slanted cut about 4 millimeters deep, just enough to reach the resin-conducting layer beneath the bark. This precise depth triggers the tree's natural defense mechanism, forcing resin outward to seal the wound while preserving the structural strength of the wood core. Next, the flat side of the axe is used to form a horizontal lip, a guiding edge that secures the collection spout and directs the resin along a controlled path. As soon as the groove and guide are formed, milky white resin begins to seep out under internal pressure, traveling along the grain of the trunk and flowing downward by gravity. In the initial stage, the resin is collected in open cups to monitor flow rate and minimize contaminants. Once the flow stabilizes, the system transitions to collection bags pressed closely against the trunk, reducing air exposure and controlling oxidation before the resin is sent for distillation. Every 5 days, the cut surface is delicately refreshed to maintain resin pressure without exhausting the tree. With this approach, each pine yields an average of only about 3 kilograms of resin per year, yet it can be tapped continuously for decades. At the scale of millions of trees, precision in every small cut has transformed pine resin into a renewable annual resource, rather than one extracted at the cost of forest decline. And now, we arrive at the main character of today's story, the raw material behind those golden drops of pine oil. In traditional pine forests, pine nuts are still harvested entirely by hand. When cones have fully matured and dried naturally, they detach from the branches and fall to the forest floor, turning the woods into a scattered trove of riches. Harvesters walk through the forest, picking up dry cones from the ground and selecting only those that remain intact, free from moisture damage or insect infestation. This is a slow method, but one that preserves the full quality of the seeds inside. For cones that have not yet fallen, harvesters must climb the trees themselves and handpick them directly from the branches. The work demands experience and precision, as pine trunks are tall, slick, and sparsely branched. Each cone is gently twisted off to avoid injuring the branch, ensuring the tree can continue producing cones in future seasons. Each hectare of wild forest yields only about 400 kilograms of cones, equivalent to roughly 60 kilograms of raw seeds, and this output can fluctuate significantly under harsh weather conditions. In return, pine nuts accumulate an oil content of up to 60 to 70%, rich in unsaturated fatty acids, a nutritional profile that gives them exceptional value. Meanwhile, in large-scale, cultivated pine plantations, the key to dramatically higher productivity lies in mechanized harvesting systems. Trunk shakers equipped with hydraulic gripping arms clamp firmly around the lignified trunk, transmitting precisely calibrated vibrations into the canopy. This causes cones that have reached physiological maturity to fall simultaneously, allowing entire plantation blocks to be harvested in just a few days. However, full mechanization is limited for younger trees or plots undergoing genetic improvement. In these cases, harvesting crews rely on lift platforms with reaches of up to 20 meters to access the upper canopy, combined with ground workers using long poles, approximately 9 meters in length, to selectively dislodge cone-bearing branches. While this approach delivers lower yields, it offers superior control over seed quality and preserves the tree's long-term growth structure. Yet harvesting is only half the story. The true value of pine begins to emerge when resin and seeds reach the factory, where even minutes of delay can lead to resin oxidation or a decline in oil quality within the kernels. At gum rosin production facilities, each batch of 20 to 50 tons of raw pine resin is fed into heated tanks to soften the material and reduce its viscosity, transforming it from a thick, sticky mass into a uniform liquid ready for further processing. From there, the pine resin is directed into distillation towers, where it is heated to temperatures of approximately 155 to 107 degrees Celsius. The lighter fraction with a lower boiling point, pine essential oil, vaporizes first, then is condensed and collected as turpentine. The non-volatile residue that remains is resin rich in resin acids, the direct precursor to gum rosin. After distillation, the molten rosin is spread into thin layers and gradually cooled using water or forced air. This controlled, slow cooling process preserves the stable amber yellow color and minimizes brittleness or cracking between production batches. Once fully solidified, the gum rosin is cut into dense solid blocks weighing approximately 20 to 25 kilograms. These blocks are then graded based on clarity, color, and mechanical properties. From this point, lighter, acid-stable grades are directed into packaging adhesives and printing inks, while darker grades are allocated to rubber compounding, coatings, and heavy industrial materials. If pine resin enters the world of chemical industry, pine nuts follow a very different path. One focused on preserving the precious natural oil locked deep within the kernel, where even the slightest deviation can erase the highest value of this crop. At the start of this journey, whole pine cones are fed into multi-stage mechanical separation systems, where pressure, impact, and friction are precisely calibrated to break the hard woody shells without crushing the kernels inside. Husk and fibrous material are continuously removed while the raw seeds fall onto conveyor belts. Once separated from the cones, the raw seeds enter vibrating sieves combined with airflow, the first refining step in the processing chain. Here, high-frequency vibration keeps the seeds in constant motion, separating them from one another and from adhering debris. At the same time, upward air currents remove lighter impurities, fragmented shells, fine dust, wood fibers, and hollow seeds too light to remain on the sieve surface. Just before pressing, the seeds pass through low-friction dehulling machines, precisely calibrated to remove the woody shell without damaging the oil-rich kernels. After flow separation, only about 70% of the seeds meet the required size and hardness standards and are retained for cold pressing. The remainder is discarded to safeguard oil quality. At the most anticipated stage, the kernels are cold-pressed in small batches at temperatures not exceeding 40 degrees Celsius, preventing lipid degradation and preserving the oil's natural molecular structure. The resulting pale gold oil is then pre-filtered and immediately bottled in glass containers to minimize exposure to light and oxygen. On average, 100 kilograms of pine nut kernels yield only 55 to 65 kilograms of oil, placing liquid pine gold among the most expensive vegetable oils in the world, far surpassing sunflower, peanut, and even extra virgin olive oil. Yet for those concerned about weight gain and cardiovascular health, pine nut oil is a particularly compelling choice. It is rich in phenolenic acid, a compound known to promote satiety, help lower cholesterol, and significantly reduce post-meal blood lipid levels, easing the burden on the heart when the body processes high-fat intake. From an 18th century home economics exam, apple pie has now moved far beyond the family kitchen to become a billion-dollar industry, with more than 400 million pies produced each year. The creation of a premium apple pie begins with the filling, where thinly sliced apples are placed into an industrial mixing kettle, along with brown sugar, butter, and cinnamon. The most remarkable feature is the oversized mixing paddle. It rotates in a slow but powerful rhythm, allowing each slice of apple to be coated evenly in a golden syrup without breaking. Meanwhile, the pie crust begins its own journey. Flour is blended with cold butter at a temperature of about 8 degrees Celsius to preserve small pockets of butter. These butter flecks are the key to creating the thin, flaky layers that emerge during baking, a secret few outside the industry know. Once the dough reaches the ideal elasticity, a sensor-controlled roller system automatically adjusts to flatten it into uniform sheets. The dough passes through a high-speed cutter and drops precisely into pre-aligned molds. In the next stage, a filling nozzle dispenses the apple mixture into each crust using steady pressure, so that the apples remain intact and the syrup doesn't spill. A crimping machine then shapes perfectly even edges, a task once mastered only by skilled bakers. Inside a convection oven set to 185 degrees Celsius, the crust separates into delicate, crisp layers, while the apple filling thickens and becomes aromatic after about 22 minutes of baking. As soon as the batch cools, the pies are transferred directly to an automated packaging line to preserve the fragrance, crispness, and structure crafted throughout the entire production process. If you ask 100 people what their favorite popcorn flavor is, 99 of them will say caramel. Every year, millions of tons of popcorn are coated in caramel in factories around the world, creating the golden glaze that has become synonymous with movie theaters, festivals, and celebrations everywhere. The process of making caramel popcorn begins in a pressure roasting kettle, where tiny kernels are heated evenly. Each kernel naturally contains about 14% moisture, so that when the water turns into steam, a sudden increase in pressure causes the hull to burst open, transforming the starch inside into light, airy flakes. As soon as the batch finishes popping and reaches the ideal temperature, the line moves immediately to the caramel coating stage to ensure the glaze adheres perfectly. Caramel is made by cooking sugar and butter to nearly 150 degrees Celsius, the temperature at which the mixture reaches its ideal thickness. The hot mixture is poured into a high-capacity mixing drum, where rotating paddles continuously stir, allowing the caramel to spread evenly over every piece without clumping. In modern factories, this process is often done twice. The first coating forms the base layer, and the second enhances shine and crispness once cooled. When the caramel layer has bonded perfectly, the batch is cooled with strong airflow to lock in the crunch, then passes through a separation system to remove broken pieces. Each year, more than 40,000 tons of fudge are produced in just the final 3 months, with pots of bubbling sugar heating across Europe and North America, turning this silky soft confection into one of the sweetest icons of the holiday season. There's a common misconception: fudge is not chocolate candy, but a type of sugar confection that requires extremely precise crystal control. The process begins when sugar, butter, and milk are cooked to the exact soft ball stage, the temperature at which the sugar has melted just enough to create a pliable texture, but hasn't yet reached the firmness of caramel. In factories, each batch of fudge is monitored using temperature and viscosity sensors more than 200 times per minute, because even a slight deviation of a few degrees will cause sugar crystals to form improperly, making the candy grainy instantly. When the mixture reaches the proper stage, it is transferred to a beating machine that breaks down large crystals and creates a cream-smooth texture. Immediately after, the hot fudge is poured onto a marble slab, a material that draws heat very quickly, allowing the mixture to set evenly without developing large crystals. Instead of being rolled thin like many other candies, fudge is folded, turned, and gathered repeatedly, creating its signature soft, pliable, velvety structure. Once it reaches the ideal consistency, confectioners cut it into uniform blocks, each piece retaining its smooth surface and melting-your-mouth texture that few candies can rival. Farewell to the fudge production lines. We now enter an equally sweet, yet far more spectacular world, the industrial cookie ecosystem, where over 30 billion cookies are baked each year, making it one of the most consumed products in the United States. If apple pie dough requires gentle handling to preserve its buttery layers, cookie dough demands a firmer mixing force. Flour, sugar, and butter are beaten until they reach a moist sand texture. When eggs are added at just the right moment, the mixture binds together perfectly to embrace flavors like chocolate chips, almonds, or vanilla, the foundation for countless cookie variations. Once the dough reaches ideal consistency, it is transferred to the shaping machines, where more than 400 extrusion nozzles continuously press dough onto the conveyor belt. Here, rotating cutters stamp out a wide range of shapes, from classic round cookies to the signature patterns of each brand. The soft, unbaked cookies are set directly into a conveyor oven stretching nearly 60 meters, where circulating heat allows them to rise slightly, set their structure, and lock in their iconic, sweet, buttery aroma. If fudge is the soft, melt-in-your-mouth candy, then toffee is the sturdy block of caramel that dominates factories with overwhelming production volume. Toffee begins with ingredients that seem simple: sugar, butter, cream, and a pinch of salt. But unlike fudge, which relies on precise crystal control, toffee is cooked to a high temperature of about 150 to 155 degrees Celsius, where the sugar undergoes deep caramelization, creating the crisp, brittle texture no fudge can match. As the mixture begins to thicken, cream is added to enrich the flavor and balance the sweetness. Few people know that just a deviation of a few degrees can change the entire result. Toffee may become perfectly crunchy and snappable, or harden like glass. The mixture is then poured onto a metal surface for rapid cooling. As soon as the caramel reaches the threshold of setting, sharp blades cut the toffee into uniform blocks, with each cut precisely calculated to avoid cracking the delicate structure. Next, the pieces of toffee pass through a stream of melted chocolate, where a smooth coating envelops every surface. While the chocolate is still warm, crunchy roasted almond crumbs are sprinkled on top, creating the familiar traditional flavor. In many factories, this step is reinvented with countless different toppings, each adding its own distinct layer of flavor and texture. This versatility is what allows toffee to break free from the mold of traditional caramel and become a confection with hundreds of variations around the world. If apple pie still carries the warm, home kitchen charm, then cider is its fully industrialized counterpart. Each year, the world produces more than 20 billion liters of cider, turning the seemingly rustic drink into one of the most popular fruit-based alcoholic beverages on the planet. The apples are fed into an industrial steel roller grinder, dozens of rotating blades spinning at over 1,000 RPM, chop, shred, and compress them into a uniform mash of pulp and juice, maximizing extraction from every single fruit. The crushed apple mass is transferred to a pressing system to separate the juice, which is then pumped into fermentation tanks. Here, yeast converts the natural sugars into alcohol and releases the signature aroma of cider, a process that lasts anywhere from 7 to 21 days, depending on the production style. When the cider reaches its desired clarity and flavor profile, it is filtered, adjusted for alcohol content, and bottled. From whole apples to finished beverages, a closed-loop production line can yield thousands of liters of cider every hour. To produce a complete batch of eggnog, the journey begins with eggs passing through a strict inspection system. Each one must clear multiple quality checks before entering the automatic egg separation unit. In the past, workers had to crack each egg by hand, a slow process prone to shell contamination. But today, high-capacity separators can handle tens of thousands of eggs per hour. A gentle pressure blade opens the shells along the precise line, allowing the yolk and white to slide into two separate channels without ever being touched by human hands. The yolks are then blended and combined with milk and sugar to form the base mixture. Next, hot milk is poured into the yolks at a sensor-controlled rate, ensuring the mixture emulsifies smoothly without cooking or curdling the eggs. Once fully homogenized, the mixture moves into a heating system for pasteurization before entering a homogenizer, where high pressure breaks down fat particles and creates eggnog's signature velvety thickness. The mixture is then rapidly cooled to 4 degrees Celsius to lock in its texture before going into an aseptic filling line, capable of processing tens of thousands of liters per hour, completing the production of this iconic holiday beverage. Did you know that creating a bottle of fine whiskey can take more than 100 years? 80 years for an oak tree to mature, and decades more for the spirit to rest in the cask. That's why whiskey is often called the liquid gold of time. The journey of a single drop of whiskey begins with barley still lying dormant. The grains are soaked, encouraged to germinate, then finely milled and mixed with hot water at 63 degrees Celsius to activate enzymes and release a sweet liquid known as wort. This mixture is transferred into fermentation vessels, where yeast converts sugars into alcohol and forms hundreds of aromatic compounds, the foundation of whiskey's flavor profile. When the fermented wash reaches about 8% alcohol, it undergoes 2 rounds of distillation to separate the pure alcohol vapors, raising the strength to nearly 70% ABV. The young spirit is then moved into oak casks whose interiors have been toasted or charred by coopers until the wood turns deep brown or even black. This cooked wood generates vanillin, caramel notes, and smoky undertones, core flavors the whiskey will gradually absorb. During the long years of maturation, the cask no longer contributes raw aromas, but instead becomes an environment where the spirit constantly interacts with temperature changes and oxygen. Each cycle of heat and cold causes the whiskey to expand and contract, seeping deep into the wood to draw out tannins and structure. While about 2% of the whiskey evaporates each year, a loss known as the angel's share. Over time, the color deepens, the flavors round out, and the unique character of each cask emerges. When the whiskey reaches its desired maturity, master blenders craft the final composition, adjusting the strength before bottling, creating a whiskey that carries the distinct identity of its distillery. When raisins arrive at the processing facility, the first step is preliminary sorting. A combination of vibrating screens and suction fans removes dry leaves, stems, dirt, and other large debris. This is a crucial preparation stage before the raisins move on to a more thorough washing process. After sorting, the raisins are further cleaned using a high-pressure water spray system. Powerful jets of water wash away any remaining dirt and bacteria on the surface of the raisins. With a processing capacity of up to 10 tons per hour, this system ensures a fast and efficient cleaning process without compromising the texture or natural flavor of the raisins. After the cleaning process, the raisins are transferred to a modern sorting system that uses optical technology. The machine scans each raisin with infrared light to detect and remove any that are damaged, misshapen, or do not meet standards for size and color. Although the technology is highly accurate, to ensure the highest quality, the factory still maintains a team of skilled workers for a final manual inspection. Using their trained eyes and experienced hands, they carefully check to make sure only the best raisins proceed to the next stage. With the sorting process complete, the raisins are transferred to the packaging line, where they are sealed in high-quality packaging. Each pack contains about 250 grams of raisins, just the right amount to satisfy consumers with this naturally sweet snack. Thanks to an automated packing system, the facility can package up to 3,000 packs per hour, ensuring the product reaches global markets quickly and efficiently. And now comes the most anticipated part, when fresh, juicy grapes move beyond their natural charm and begin an entirely different journey, becoming seductive, full-bodied wine. From timeless, memory-laden classics to refined modern flavors, the secrets behind the winemaking process are about to be revealed. The story begins as massive trucks filled with freshly harvested ripe grapes roll into the winery's receiving area. Here, the grapes are unloaded into enormous stainless steel containers and swiftly transferred onto a modern conveyor system where speed meets delicacy to preserve the quality of every single grape. One of the most remarkable aspects of this process is that the grapes are not washed with water. This is because their skins carry a natural layer of wild yeast, an essential component for fermentation. Washing the grapes would strip away this precious layer, diminishing the wine's distinct flavor and hindering the fermentation process. Instead of washing, the grapes are cleaned manually. Skilled workers carefully remove leaves, stems, damaged berries, and other impurities, ensuring cleanliness while preserving the grape's natural, living essence. After being carefully selected, the grapes are passed through a specialized machine to undergo the destemming process. This step utilizes advanced technology with state-of-the-art equipment designed to remove the stems from each cluster without damaging the grapes themselves. Once separated from their stems, the grapes continue gently to the next stage. Following destemming, the grapes are sorted using an optical system supported by cameras and special lighting. These machines use image scanning and infrared technology to precisely analyze each individual grape, removing those that do not meet quality standards. Capable of processing up to 20 tons of grapes per hour, this system optimizes the workflow and significantly enhances production efficiency. Next, the grapes are fed into massive crushing machines, capable of processing up to 10,000 pounds of grapes per hour. These machines are meticulously designed with gentle crushing rollers and rotating paddles that press the grapes softly and carefully, without breaking the seeds. A crucial detail in winemaking. If the seeds are crushed, they release tannins that can cause the wine to develop an undesirable bitter taste, compromising the delicate flavor profile that winemakers strive to achieve. Did you know that before machines, grapes were once pressed by bare feet? In many long-standing winemaking regions, stomping grapes wasn't just for extracting juice. It was also a way to connect with the land and the harvest. The feet acted as natural sensors, pressing gently to preserve the wine's delicate flavor. Though this practice is now rare due to hygiene standards, millions of glasses of wine are still raised, with few remembering that the journey once began with a pair of feet and ended in a flavor full of emotion. The grape juice, after being pressed, is transferred to large fermentation tanks to begin the process of developing the wine's distinctive flavor. This process typically lasts from 10 to 30 days, depending on the grape variety, sugar content, and environmental conditions. Throughout this process, natural yeast triggers a chemical reaction, converting the sugar in the grape juice into alcohol and carbon dioxide. As CO2 is produced during fermentation, it pushes the grape skins to the surface, forming a layer known as the fermentation cap. This cap needs to be regularly pushed down to allow the wine to continue absorbing color, aroma, and tannins from the skins, while also preventing the growth of bacteria and mold. After the fermentation process is complete, the wine needs to be clarified and separated from the solids to remove grape skins, seeds, and other remaining impurities. This step is typically carried out using filters or specialized equipment that efficiently separates the wine from the grape pomace. Filtration not only makes the wine clear and visually appealing, but also reduces the presence of compounds that could cause bitterness or off flavors. Once filtered, the wine is transferred to aging barrels or proceeds to the next stages of production, ready to develop its perfect flavor profile. For premium red wines, after filtration, the wine is transferred into oak barrels for aging, where the true magic happens. The wine is carefully pumped into the barrels, where it rests for 12 months to over 2 years. Aging in oak not only allows the wine to absorb the distinctive aromas of the wood, but also helps soften the natural astringency of the grape tannins, creating a smooth, layered texture in every sip. Finally, when the wine has reached its peak maturity and perfection, it is pumped into automated bottling machines, where the bottling magic begins. These machines, equipped with advanced sensors, ensure that each bottle is filled with milliliter-level precision, guaranteeing perfect balance in every sip. The bottling process is fast and efficient, with the capacity to fill up to 3,000 bottles per hour, highlighting an impressive level of automation and quality control. After bottling, the wine is labeled, sealed, and carefully packaged, ready to be distributed to markets around the world. From sun-drenched vineyards to the shimmering glass on the table, the story of each drop of wine is a legacy of land, time, and dedicated hands. Over thousands of years, that sweet juice has transformed from ancient ritual to a symbol of modern sophistication. And today, in just one sip, we can taste both tradition and innovation, blended together in the most captivating way. More than just a drink, champagne is a national pride, a true symbol of the French way of life. In the 17th century, people whispered that Dom Pérignon, the Benedictine monk, was the father of champagne. In truth, the sparkling phenomenon had appeared naturally before, but Dom was the one who perfected the technique and laid the foundation for the world-famous sparkling wine we know today. By the 18th century, what was once dismissed as a cellar flaw had undergone a spectacular transformation, becoming the king of wines and the wine of kings, closely associated with King Louis V, the French aristocracy, and later the whole of Europe. Today, champagne is often misused as a generic term for any sparkling wine at weddings, festivals, or sports celebrations. But few realize that only sparkling wines made from grapes grown in the Champagne region, crafted under hundreds of strict regulations, truly earn the prestigious AOC Champagne label, with prices reaching thousands of euros, often 5 to 10 times higher than Italian Prosecco or Spanish Cava. Currently, the giants ruling the sparkling wine world include Moët & Chandon, Veuve Clicquot, and Louis Rittera, with their most luxurious cuvées such as Dom Pérignon, La Grande Dame, and Cristal, ultimate icons of sophistication in the champagne universe. Unlike red wine, with its warmth and lingering finish on the palate, champagne enchants with its explosion of millions of bubbles, carrying the pure aromas of green apple, ripe pear, and a hint of toasted bread. Yet, this is but a single brushstroke in the grand portrait of Champagne. Now, let us take you to the very first stop, the vineyards at harvest season, where every legendary bottle of sparkling wine begins its journey. One of the key reasons behind Champagne's timeless value lies in its grapes. Among the hundreds of wine grape varieties across the world, only Chardonnay and Pinot Noir stand out as the most suitable candidates, providing the acidity, purity, and depth of flavor essential to this sparkling wine. And remarkably, even when these same grapes are grown in Burgundy, Bordeaux, or California, they can never replicate the true taste of Champagne. Only the region's distinctive chalky soils impart that unique minerality, freshness, and balance. In other words, nature itself has appointed Champagne as the birthplace of this legendary sparkling wine. But even the finest grapes are not enough. Across tens of thousands of hectares, every single Champagne must be harvested entirely by hand. This is not merely a regulation, but a sacred ritual. The official start of harvest can only be declared by a technical committee, after closely monitoring physiological ripeness, sugar levels, acidity, seed and skin condition, and the taste of the pulp. Only when all these factors reach the perfect balance is each village granted permission to begin picking. From the break of dawn, hundreds of workers spread across the vineyards. With sharp, specialized shears, they carefully snip each cluster as though handling a treasure, placing it gently into shallow wooden crates to avoid crushing. To qualify, the grapes must be intact, neither bruised nor wilted, selected right in the vineyard through the keen eyes and seasoned hands of experienced pickers. Immediately afterward, each crate is labeled with the vintage, vineyard name, and exact origin, ensuring absolute transparency and traceability. Unlike red wine, where grapes are typically crushed and fermented with their skins to extract color and tannins, Champagne begins with absolute purity. Immediately after harvest and sorting, the fresh clusters must be transported to the press house as quickly as possible, keeping the berries intact to prevent oxidation and avoid any bitterness from the seeds or skins. What makes Champagne unique is that the grapes are always pressed whole, in bunches. This long-standing tradition is closely tied to the classic coquard or basket presses, designed to spread the clusters evenly and apply only gentle pressure. Today, many producers have adopted modern pneumatic presses, which allow for more precise pressure control while still honoring the philosophy of pressing, not crushing. This stage is the cornerstone of the Champagne method, pressing with utmost delicacy to obtain the clearest, purest juice, pure enough to make white wine even from red grapes. It is the very first step, and also the reason why Champagne houses guard their pressing techniques as a vital trade secret. After pressing, the grape must undergo clarification for at least 12 to 24 hours. Winemakers may choose oak barrels, which add richness, subtle notes of butter and vanilla, and a rounded structure, particularly favored in prestigious vintage champagnes. For non-vintage cuvées, however, the juice is usually kept in stainless steel tanks to preserve freshness, purity, and the wine's characteristic fruitiness. This settling process allows solid particles, soil residues, and grape skin fragments to sink to the bottom, leaving behind a crystal-clear juice, an essential preparation before fermentation begins. The first fermentation takes place much like that of still wine. Natural or added yeasts convert sugar into alcohol and CO2. Since the process occurs in open vessels, the CO2 escapes, leaving behind a young wine with an alcohol content of around 11%. At this stage, it is not yet champagne, but merely the base wine, the overture before the grand symphony that is yet to come. If champagne were a symphony, blending would be its most crucial act of harmony. After the first fermentation, each vat of base wine carries its own character and flavor, shaped by the grape variety, the vintage, the terroir, and the method of maturation. task of the cellar master, the maestro of the cellar, is to taste hundreds of these different base wines and combine them in perfect proportion. This process demands refinement, experience, and an extraordinary memory of taste. The goal, to ensure that every bottle of champagne expresses the house's signature style, no matter whether the year's weather was generous or unforgiving. Once blended, the base wine is transferred into special glass bottles and swiftly sealed with a steel cap, much like a beer bottle. It is here that the magic begins. The yeast starts consuming the added sugar, producing alcohol and CO2. This time, however, with the bottle tightly sealed, the gas cannot escape. It dissolves into the liquid, creating the signature effervescence of champagne. Beyond the bubbles, this second fermentation also generates lees, spent yeast cells that, as they break down, release complex organic compounds. These impart aromas of toasted bread, roasted nuts, and baked butter. Layers of flavor found only in truly fine champagne. By law, non-vintage champagne must rest in the cellar for at least 15 months, while vintage champagne requires a minimum of 3 years. In practice, many producers age their wines far longer. 5, 7, even 10 years, unlocking greater depth and complexity. After sufficient aging, the bottles of champagne enter the riddling or remuage stage. This traditional technique is designed to collect all the lees into the neck of the bottle. The riddler places the bottles on a wooden rack with angled holes, called a pupitre, and gently rotates each bottle a quarter turn every day while gradually increasing its tilt. Over the course of several weeks, the sediment slowly settles into the neck near the cap. Today, many champagne houses use gyropalettes, automated rotating machines to save time and labor. Yet in prestigious cellars, the art of hand riddling is still preserved, honored as a symbol of tradition. Riddling is a crucial step in preparing the bottles for the next stage, degorgement, the removal of the sediment. This is the magical moment. The neck of the bottle, where the lees have collected, is plunged into a deep freezing solution, solidifying the sediment into a small ice plug. When the cap is removed, the pressure of the CO2 forcefully ejects the plug, carrying the lees out with it. The result is a crystal clear champagne, pure and brilliant, though now slightly reduced in volume. To restore the lost liquid, the winemaker adds a mixture known as liqueur d'expédition, composed of base wine and a precise amount of sugar. This final touch defines the champagne's style: brut nature, extra brut, brut, sec, demi-sec, or doux. The level of sugar determines the taste profile, offering different sensory experiences for every connoisseur. At the same time, the artistry behind crafting the cork and wire cage, the silent gatekeepers of champagne, is equally vital. Unlike ordinary wine corks, a champagne cork is composed of several layers of natural oak bark, strong enough to withstand pressure 3 times greater than that inside a car tire. The wire cage, or muselet, serves as a suit of armor, fastening the cork securely and preventing it from bursting out under the force of the gas. Together, this duo has become an enduring symbol of champagne. Steadfast and reliable, yet irresistibly enchanting the moment they are released, marking the opening of a celebration and the beginning of joy. And when everything is complete, each bottle of champagne is sealed with a cork and secured by its wire cage. This iconic image has become inseparable from champagne itself, a universal symbol of celebration and festivity around the world. The bottles are then left to rest for several more months in the cellar, allowing the flavors to harmonize and stabilize. At last, as they emerge from the darkness into the light, champagne is ready to carry within it the legacy of years of meticulous craftsmanship. From the vineyard to the cellar, from years of meticulous aging to the resounding pop of the cork, champagne is not merely a wine, it is the very essence of French artistry, a symbol of luxury and celebration. Every bubble carries the resonance of tradition, the precision of craftsmanship, and the promise of unforgettable moments. To open a bottle of champagne is not simply to drink, but to partake in an eternal ritual of elegance.